And we're working on the possibility that kaolin, which is aluminum silicate, may be precipitated by the same kinds of nanobacteria that precipitate carbonate. These little balls are probably nanobacterial cells. You see, this flake is made of aggregates of these little balls, and eventually you end up with nice hexagonal flakes. So this mineral, we think, is being precipitated by a combination of biologic, that is nanobacterial, plus inorganic precipitation, the inorganic making the nice crystal forms.
Wow. Well, don't talk too much because this is going to go to the web and you probably didn't publish yet.
Oh no, that's not published yet. I mean, we do all sorts of things that are not published yet.
Okay. By the way, how do you, when do you decide that you have to publish something? That when I mean, you have so many things going on. You have probably different branches of research. When do you think that something is worth it to be published?
That's a good question. When you think you've accomplished enough to show that this is really new, and you never get all the answers, okay? I mean, one can never make the mistake of thinking, I'm going to solve everything that's to be solved about this particular problem. What you do is you go as far as you can and then leave it to others who have more expertise in various fields to carry it on in other ways. For example, I'm not a biologist. I make all these publications about nanobacteria. I cannot determine their biological characteristics. That takes a professional in another field. So I'm hoping that by publishing these things, other people will take the torch, let's say, and carry it on into fields in which they're more an expert.
Let's talk about the siliciclastic versus the carbonatic systems. Why do you think they are always like so well differentiated in the books, in the textbooks, in literature? Nature has like more a continuum, right? Is this just something that we need just to classify?
Well, okay, for my own example, I guess I'm one of the few people who works in both systems, because I was taught all about sandstone petrography when I went to college, and then when I came to do my PhD, I did my PhD on carbonate rocks, which nobody at my college, Penn State, knew anything about carbonate rocks, so that was something totally new. And then when I came down here, I've continued to work both on sandstones and carbonate rocks. I think there's a complete gradation between them. They have many principles that work equally for both. For example, beach sands are well sorted, beach carbonates are well sorted. Lagoonal muds are poorly sorted, lagoonal carbonate muds are poorly sorted. There's a great similarity between the two. So I try to integrate the two together.
And so is anybody now working on the mixed systems?
There probably are some, but I can't recall the names.
Which relationship between your life as a scientist and your private life in your family?
Well, I'm madly in love with my wife, of course, even after 63 years. And she used to go with me to Italy at least every other time. And she's helped me in the field in places like the Australian desert and Italy and backwards places in the United States like West Virginia, for example. And so we get along very well. I'm also a dedicated church member. So I'm one of the few geologists, I guess, who's also very religious. Yeah.
Is that a problem to be a scientist?
Some people think it's a problem, yes.
So what do you think about life, like we just talked about life on Mars?
Yeah.
Which relationship with your religion thoughts?
No problem. I mean, if God was able to create stars, universes, the whole works, if he decides to make life on Mars, he can. That's no problem to me. No problem at all. In fact, we're working on these nanobacteria, I think, are the key to the origin of life on Earth, because they're so small. Life on Earth must have started extremely small, like a DNA chain that's very short and very primitive things. And I think we can see here, if biologists would get off their butts and go to Viterbo, they would see, I think, exactly like life began 4 billion years ago in these organic slimes. You can trace every stage in the beginning of cell development, but they haven't done it yet.
So what about
I think basically God designed the basis of the universe, but small-scale features maybe they've developed by other means. And I certainly don't agree with the people who believe in a 6,000-year-old Earth or extremists like that. I think that's way off base.
would you like to say anything to students that are coming out from earth science and they are looking for a future in earth science?
Yeah, I would say that don't be afraid to follow radical concepts, even if your professors say you're nuts or something like that. Have the courage to follow up your own discoveries.
Okay, thank you very, very much, Bob.
Prego.
Ciao.